Next question. Find the sum of all the multiples of 2 and 3 between 100 and 200. Between means here this 100 and 200 are excluded here. So not included. Excluded means in between we have to find. One more thing we have to remember, 2 and 3 means here a number that is divisible by 2 and 3. So that is the multiple of 6. Multiple of 6. Here we have to find all the multiples of 6 between 100 and 200. That is the question here. Then after first we have to write all the multiples of 6. So in this given problem, so the number, first number which is divisible by 6. Suppose here you see it is not included in 100. 101 it is not divisible by 2 and 3 also, and 102. So 102 it is divisible by 2 and at the same time divisible by 3. So the first number is here 102. It is also divisible by 3. So it is also divisible by 6. So just we can see a number which is divisible by 2 and 3, that is also divisible by 6. So that's why here first number that is divisible by 2 and 3, that 3-digit number, that is also 3-digit number, that is divisible by 2 and 3 and also the multiple of 6. So here we can write next number is 108. Here you see 108 is divisible by 2 and 3, it is also divisible by 6. Similarly you can add 6, we can get 114 and 120, so on. What is the last number? You can find out. 199 is there. Just you divide by 6 here. 6 3s are 18 and 119. 6 3s are 18. So 1 is the remainder. So means here 198 exactly divisible by 2 and 3. It is also divisible by 6 now. So now we know the sequence. So the numbers which are between 100 and 200 and that are divisible by 2 and 3 and also the multiple of 6 here. These are. Now we have to find how many such numbers are there here. What is the first number? What is the last number here? And now I am going to find here. You see, first this is in AP. First this sequence is in AP. A1 is equal to first number A1 is equal to 102. Here the common difference is equal to A2 minus A1 is equal to A3 minus A2. 108 minus 102 is equal to 114 minus 108. In the both the cases it is 6 is equal to 6. Then this sequence is in AP. The given list of numbers that are in AP. So in AP, so we can find out number of numbers in that are multiples of 6 in between 100 and 200 we have to find. So here AN is equal to 198. 198. You know that AN is equal to A1 plus N minus 1 times D. This is the formula to find the nth term of the given sequence AP. So here substituting all the, already I have written A1 value, D value, and this is D value here, this is the D value. So AN value, substituting this 198 is equal to 102 plus N minus 1 times it is 6. So first we have to transpose this 102 this side. 198 minus 102 equal to n minus 1 times 6. So 198 minus 102, so subtracting this one you can get 996 equal to n minus 1 times 6 here, divided by 6 on both sides, divided by 6 on both sides. This one will be cancelled. 16, 6 ones are 6 and 60. So here we can write 16 is equal to n minus 1. 16 equal to n minus. Transposing this one this side here, this one becomes 16 plus 1 equal to n. So here n value is 17. So how many multiples are there? So here 6 multiples, 17 6 multiples are there here. 17 6 means here 17 numbers that are divisible by 2 and 3. Divisible by 2 and 3. Now sum of all the multiples you have to find. To find the sum of all the multiples here, the formula is here Sn equal to n upon 2 times a plus l. First term a1 plus l, last term that is an. You can write here an. Instead of l you can write an. a1 plus an. So now n value already you got 17 upon 2. a1 is 102 plus an is 198. So here 17 upon 2 times, so this one becomes 300. So simplifying this one, 17 times 300 upon 2 to 150. So here 17 times 150. So now the value will be 0. 15 sevens are 105. 15 ones are 15, 10, 25, 2550. Once again I will do 15 sevens are 105 and 15 ones are 15, 15 plus 10, 25, 2550. Sum of all the sum of the digits here, sum of the multiples of 2 and 3 or sum of the multiples of 6 in between 120 is 2550.